Hey guys, welcome back to the CAIE Lab. In today's video, we're going to continue our chapter on alkenes. But before we do that, I want you to go through a few important highlights that I forgot to mention in the previous video. And they're important for your exam, so let's cover them fast. Alright, so all those reactions which use UV radiation are known as photochemical reactions. An example of it is photosynthesis, which uses the UV radiations from the sun to start its chemical reaction. And substitution reaction is also an example of it. Furthermore, substitution reactions will continue until all the hydrogens are replaced by the halogens. And number of hydrogens replaced is equal to the number of hydrogen halide formed. Hydrogen halide are those compounds that are formed in the substitution reaction, and they are the second product formed. Here, hydrogen chloride is an example, and it can either be hydrogen fluoride or hydrogen bromide. Okay, so the last thing is that the longer chain alkanes are less volatile. And volatility means that it is the tendency of a liquid to evaporate easily, which means that longer chain alkanes do not evaporate easily. Alright, so now that we have covered those highlights, let's continue from where we left off. Alkenes. Alkenes are the hydrocarbons, and they are unsaturated hydrocarbons because they have a carbon-carbon double bond. Alkenes have a general formula of CnH₂n, where N represents the number of carbon atoms. Alkenes are also named, and their name ends on -ene. And here is a whole series of alkene compounds with their molecular formula. Now the thing to notice here is that there is no methane here, because a double bond requires 2 carbon atoms. However, methane has only 1 carbon atom, and therefore alkene starts from ethene and not methane. Now, you may memorize this whole series because they might be helpful in your exams. Now, let's talk about how to derive the molecular formula of alkanes from their general formula. The general formula of alkane is CnH₂n, and ethene has 2 carbon atoms, so N is equals to 2. Let's put in the value of N. We're going to write CnH₂n. This is the general formula, and C2H2 multiplied by 2. So this gives us C2H4. And this is how we derive the molecular formula of ethene. Now let's focus upon how to draw the displayed structural formula of ethene. Firstly, draw the 2 carbon atoms and then join them together by the double bond. Now, there's only 1 double bond in the alkenes, so the rest bonds will be the single bonds. Carbon atom is a group 4 element, so it makes 4 bonds. Let's complete the 4 bond of each carbon atom. This carbon atom has 2 bonds of it already made, so let's complete the rest 2 like this. And we're going to do the same thing with this C. And now we're going to put the H elements along with each line. Here comes the H first, then here, and here. And this is how we've drew the displayed structural formula of ethene. Now let's focus upon how to write the condensed structural formula. Firstly, you have to make the double bond. That is the most important thing. Now we're going to see that what is beside it. We have CH2 on the left side of it. We're going to write CH2 here. Now on the right side, it's also CH2. We're going to write CH2 again. And this is how we have written down the condensed structural formula of ethene. Now the next example is propane. And we're going to use the same general formula to write down its molecular formula. And for the displayed structural formula, we're going to use the same method. Firstly, we're going to draw the 2 carbon atoms, and then we're going to join it together with a double bond. Now, propane does not have 2 carbon atoms. Instead, it has 3. So we're going to complete the number of carbon atoms. We're going to draw another carbon atom to complete 3 carbon atoms. And then we're going to complete the 4 bonds of each carbon atom. Let's start with this one. We're going to draw the 4 single lines along with it. And this C has 2 bonds of it already made, so we're going to draw the rest 2 here. And then we're going to do the same thing with this C. It has 2 bonds already made here, so we're going to draw the rest 2 here. And now we're going to put H element along with each line, with here, 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 and here. And this is how we have drew the displayed structural formula of propene. Now, how to write the condensed structural formula? It's the same thing again. Firstly, draw the double bond, and then see that what is beside the double bond. Here on the left side we have CH2, so we're going to write the CH2. And on the right side we have CH only, so we're going to write CH. And then as you can see that the C is connected with a single bond, we're going to draw a single bond here. And then we're going to write the CH3, which is on the right side of the single bond, CH3. And this is how we have written down the condensed structural formula of propane. The same thing is going to happen with butane. Use the general formula to write down the molecular formula, and then with the structural formula, firstly draw the double bond, and then write down the C's together. And there's only one double bond mandatory in the alkane, so the rest C's will be joined together with a single bond. And this is how we drew the displayed structural formula. Then you have to write down the condensed structural formula, make the double bond, then write what is beside the displayed the double bond, and this is how you have written down the condensed structural formula. Alright, so take a moment to solve this example on your own. Pause the video right now, and when you're ready, resume it to see the solution. Alright, so let's solve it together. So we're talking about heptane here. Firstly, we're going to use the general formula to write down its molecular formula. The general formula of alkane is CnH₂n, and N is 7 here, so we're going to put in N as 7, and 2 multiplied by 7. And this is how the molecular formula of heptane is C7H14. Alright, so now let's draw the structural formula of heptane. Firstly, we're going to write down the 2 C's like this, and then we're going to join these C's together with a double bond. Now let's complete our rest C's, because there are 7 C's here, so we have to draw 5 more C's here. We're going to draw 1, 2, 3, 4, and 5. And now we're going to join each C together with a single bond, like this. Now let's complete the 4 bonds of each C. Let's start from here. It is 1 bond already made for it, so let's complete the rest 3. Let's complete the rest 2 of it. The rest 2 of these 2. And it has 3 bonds of it already made, so we're going to just draw the last 1 bond of it. And it has 2 bonds of it already made, so we're going to just complete the rest 2. And this is how we've completed all of the bonds. Now let's put H element along with each line. H comes here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and here comes the 14th. And we have whole 7 C's with 14 H. Now let's draw the condensed structural formula of the heptane. Firstly, just write down your double bond, and then what is beside it, we're going to see that with this double bond on the left side of it is CH2. We're going to write CH2 here, and then on the left side it is CH only. We're going to write CH, and then we're going to see that what is on the right side of the CH, it's a single bond. And then we're gonna write the CH2, and there's a single bond again, and there's another CH2. We're gonna write that, and there is another single bond, another CH2. But let's count first how many CH2s are here. We have 1 CH2, we have 2nd CH2, we have 3rd CH2, and we have 4th CH2. So we're gonna write 4 CH2s. We have 3 CH2s written, so let's complete the last one. And then we're going to draw the single bond again, and this is CH3 written at the right side of this single bond, so we're going to write CH3. And this is how we have completed the condensed structural formula. To further shorten out, we're going to just put a bracket. Let me show you how to do that. Firstly, write down CH2 double bond CH, and then a single bond and CH2 with a bracket, and outside written 4 because we have 4 CH2s, so we're going to just shorten out to tell that there are 4 CH2s in this form, and then we're going to just complete it by putting a CH3 at the end. And this is how we've written the condensed structural formula of heptene. Alright, so the next thing is the physical properties of alkenes, which are very similar to those of alkanes, so let's go through them briefly. So the first thing is that the melting and boiling point of alkenes increases down the family due to increase in the molecular mass, and the reason behind this I've already told in the previous video. And the second thing is that the density increases down the family due to the increase in the molecular mass. Third thing is that the viscosity increases down the family due to increase in the molecular mass, and viscosity is the thickness of liquid. And the flammability decreases down the family due to increase in the carbon atoms. And alkanes are insoluble in water but soluble in organic solvents. The organic solvents are the tetrachloromethane and benzene. Alright, so the next thing to focus upon is the chemical properties of alkenes. In total, there are 2 chemical properties of alkenes. The first chemical property is the addition reaction. The addition reaction is the reaction in which only one product is formed. And this is the exam definition for the addition reaction. Because often in the theory paper, it comes up a question that says that what is the addition reaction? And you just have to write that it is the reaction that forms only one product. Alright, so the second chemical property is the combustion reaction, in which alkenes react with oxygen to produce carbon dioxide and water with the evolution of heat and light. The combustion reaction is further broken down into 2 types, the complete combustion and the incomplete combustion. The complete combustion occurs in the sufficient supply of oxygen, whereas the incomplete combustion occurs in the insufficient supply of oxygen. The products of complete combustion is the carbon dioxide and water, whereas the products of incomplete combustion is carbon monoxide and water. Alright. Furthermore, addition reaction of alkenes is actually 4 addition reactions. The first addition reaction of alkene is with hydrogen, then it's with bromine, then it's with steam, and lastly, it is with another alkane. And the last addition reaction is also called polymerization, which we're going to study more further in the organic chemistry. So now the first addition reaction of alkene is with hydrogen, which is also known as hydrogenation. In this reaction, an alkene reacts with H2 hydrogen to form an alkane. For example, look here, it is ethene that reacts with hydrogen in the presence of nickel, which acts as a catalyst here. And a catalyst is actually a compound, or it's actually a substance that increases the rate of reaction, allows the reaction to become faster. And it also occurs in high temperature and high pressure, and the product here is ethane. The double bond here is broken down into these 2 single bonds right here with an addition of 2 H elements and forming ethane. The next example is of butene. The butene reacts with hydrogen in the presence of nickel, high temperature and high pressure to form butane. Alright, so the 2 important points to note down is that this above reaction is the formation of alkane. And this is also known as the margarine formation. And margarine is actually a substitute for butter, which is used in the everyday cooking, and it is made up by adding hydrogen to vegetable oils. And this was an additional fact. Alright, so the second addition reaction is the addition reaction of alkane with bromine, which is also called bromination. And in this reaction, alkene reacts with Br2 bromine to form a dibromoalkane. It is called dibromo because it only contains 2 bromine elements after reacting with bromine. Here, ethene is reacting with bromine in the presence of high temperature to form dibromoethane. Alright? And it's called an alkane at the end because the double bond is broken down and it becomes a saturated compound, so it's called alkane. So it's called dibromoethane. So here's another example of butene. Butene, whenever reacts with bromine at high temperature, it forms dibromobutane. So another thing to note down here is that addition of bromine is actually a test for the unsaturated compounds. If a solution contains an unsaturated compound, then whenever bromine is added, which is of red-brown color, the solution turns from red-brown to colorless because it contains a double bond, an unsaturated compound. Alright, so the next addition reaction is the addition reaction of alkene with steam, which is also called hydration. In this reaction, alkene reacts with water to form alcohol, which is actually another organic compound, and it's the derivative of hydrocarbon, which we're going to study further in our next episode. So here is the example of ethene. Whenever ethene reacts with water in the presence of H3PO4 phosphoric acid being a catalyst, 300 degrees Celsius temperature and 60 to 70 atm pressure to form ethanol. Another important conversion here is of this 1 atm to kilopascal, which very often comes up in your exams, asking you to convert atm into kilopascal and kilopascal into atm. So you must remember that the 1 atm is equal to 100 kilopascal, and here the 60 atm temperature is actually equal to 6,000 kilopascal. The next example is of butane. When it reacts with water, it forms butanol. So another fact which says that this reaction is also the industrial preparation of alcohol. Alright, so now let's test your understanding with some past paper MCQs. I've compiled these questions for you and I want you to master them alongside the syllabus. Alright, so let's solve the question number 1. It says that which statement about alkanes is correct? Option 1 says that they contain carbon, hydrogen, and oxygen only. Yes, they do contain carbon, and yes, they do contain hydrogen, but they do not contain oxygen because alkane is a pure hydrocarbon, and therefore it's not the derivative, so this is wrong. The second option says that they are saturated compounds with only single ion bonds. Well, they do are saturated compounds, but they do not contain the ionic bonds because in the whole organic chemistry, we're just talking about the covalent bonds. So this is also wrong. Now the third MCQ says that the alkanes with longer chain lengths are more volatile. No, this is wrong because we just read above that the longer chain lengths are less volatile because they do not evaporate easily. Now the last option says that they react with chlorine, which is a halogen, in a substitution reaction. Well, that is absolutely correct because whenever alkanes react with halogen, that reaction is always a substitution reaction. So we're going to encircle D. Now let's talk about the question number 2. The question number 2 says that which row shows the conditions used to manufacture ethanol from steam and ethene? Now ethene here is alkene, and whenever there is a reaction between alkene and steam, then that reaction is the addition reaction and the product is alcohol. The conditions are that the temperature is 300 degrees Celsius and the pressure in kilopascal is 6,000. We cannot consider 60 because they're not talking about atm. So therefore 60 is wrong. The right answer is D. Alright, so now let's move on to the question number 3. The question number 3 says that which structure represents an unsaturated hydrocarbon? In an unsaturated hydrocarbon, there is always a double bond between the carbon and carbon. Let's take an example of carbon double bond O. This cannot be considered right because the double bond must always remain between the two carbon atoms and not any other element. So let's check that which option meets this requirement. The option number 1 only represents alkane with single bond, so this cannot be considered right. The option B has the double bond, but it is between carbon and oxygen and not carbon and carbon, so this is also wrong. The option C tells us that there is only a single bond, so this is representing alkane and this is also wrong. Now the last option has a double bond and it is between the carbon and carbon, so this is correct. Alright, so now let's move on to the question number 4. The question number 4 says that which type of reaction takes place when pentane reacts with chlorine? Pentane is an alkane, and chlorine is a halogen. And whenever there is a reaction between halogen and alkane, that's always a substitution reaction. It cannot be polymerization, it cannot be the addition, and it cannot be cracking. So the right answer is substitution reaction. Well, let's move on to the question number 5. The question number 5 says that the molecular formula of compound Z is C4H10. Which row identifies the substance that reacts with Z and describes the type of reaction that occurs? Now let's just first discover that what is C4H10. I'm firstly using the general formula of alkene, which is CnH₂n. Here carbon atom is equals to 4, so N is 4. C4H2 multiplied by 4, it's gonna be C4H8. Both of the molecular formulas are not matching, so this is wrong. It is not an alkene. Let's put the general formula of alkane, which is CnH₂n plus 2. C4H2 multiplied by 4 plus 2 gives us C4H10. So yes, both of the molecular formulas are similar, so this is an alkane. Right, so now let's check that alkane reacts with which substance? Yes, alkane reacts with chlorine, but it does not react with steam because we haven't read anything yet like this before. And the type of reaction in which alkane reacts with chlorine is the substitution reaction, so the right answer is B. Now let's move on to the question number 6, which says that which compound is formed when ethene reacts with steam? Ethene is actually an alkene, and steam is actually water. Whenever alkene reacts with steam, the product formed is alcohol. So therefore, ethane, which is an alkane, cannot be right. Ethanoic acid is an acid, so this is also not correct. Ethanol is an alcohol, so yes, this can be considered correct. And polyethylene is actually alkene, so yes, this is wrong again. And the right answer is C. Alright, so now let's move on to the question number 7. The question number 7 says that the diagram shows the structures of 4 molecules. And which statement about these molecules is correct? Now, as you can see, in every option, there is the name of molecular formula present. So let me show you how to derive the molecular formula from the diagrams. Firstly, you have to number the carbon atoms present inside. It's 1, 2, 3, and 4. So there are going to be 4 carbon atoms. And now we're just going to number out the hydrogen elements. It's going to be 1, 2, 3, 4, 5, 6, and 7, and 8. So it's going to be C4H8. And this is its molecular formula. Let's talk about the second diagram. How many carbon atoms are present in there? It's 1, 2, and 3, so it's going to be C3. And then what about the hydrogen atoms? 1, 2, 3, 4, 5, and 6, so it's going to be H6. And there's only one oxygen element, so it's going to be C3H6O. Now let's do the same thing with this. 1, 2, 3 carbon atoms. It's C3. Then 1, 2, 3, 4, 5, and 6 H6. And we have only one oxygen, so it's going to be C3H6O. Now it's 1, 2, 3 carbon atoms, C3. 1, 2, 3, 4, 5, and 6 H6. And there's only one oxygen element, so it's going to be C3H6O1. Now let's just read all the options. The first options say that all 4 molecules have different molecular formula. Well, that's wrong because we can see that the 3 of these diagrams have the same molecular formula. And the option B says that all 4 molecules have the same molecular formula. Well, that's wrong too because we have only 3 molecules with the same molecular formula. So this is wrong. And the third option says that only 2 molecules have the same molecular formula. Well, that's wrong again because not 2 molecules have the same molecular formula, but 3 do have. And the third option says that only 3 molecules have the same molecular formula. Well, that's absolutely correct because yes, 3 of them have the same molecular formula, so the right answer is D. Now, let's talk about the question number 8. It says that 3 hydrocarbons are separately mixed with aqueous bromine. And which row gives the correct observation for each hydrocarbon? So let's just read the diagrams. It is representing single bond, so it is an alkane. The second diagram also is representing single bond, so it's also an alkane. And the third diagram represents a double bond between two carbon atoms, so it is an alkene. Now, the option number 1 says that color changes from orange to colorless. Well, that is wrong because we just read above that whenever aqueous bromine is added, it's actually a test for the unsaturated compound and the color changes from red, brown, or orange to colorless. So with an alkane, nothing happens, so it is wrong. Color stays unchanged. Yes, this is correct because bromine does not do anything to alkane. Color changes from orange to colorless. Yes, that's correct because bromine changes the color of alkene. So we cannot consider this whole MCQ correct because there are only 2 options correct here and not 1. Let's move on to the second option. It says that the color changes from orange to colorless. Again, that is wrong. Second thing says that the color changes from orange to colorless. Well, that's wrong. Bromine does not do anything to alkane. Third thing says that color stays unchanged. Well, that is not correct because bromine changes the color of alkane. Now let's talk about option C. It says that color stays unchanged. Yes, that is true. Color stays unchanged. Yes, that is true. Color changes from orange to colorless. Yes, that is true. Then let's read the last option. Color stays unchanged. Yes, that is true. Color changes from orange to colorless. No, that is not correct. Color stays unchanged. No, that is not correct. So the right answer here is C. Alright. So this was all for today. I hope you liked my video and understood the concept. Don't forget to hit the bell icon and subscribe to my channel. Let's meet in another video.